Welcome students. Pre-half yearly exam over. So today we are going to start a new chapter, refraction of light. So refraction of light is a phenomenon. Okay. Light can penetrate into some medium like a glass or water like this, and the transmission of light through this medium is called refraction basically, and it has some properties also. Due to those property, uh, if we dip a pencil into the water, you see the pencil look like it's bent. Okay, so this phenomena is called refraction of light, and the we are we will study about the refraction of light and its properties, and we will apply its property to our daily life. Okay, and so some property, let's move into the some properties of light. When light move from one medium to another medium, suppose when light move from air to glass or water to glass or glass to water like this, then in which direction it will bend we will show. If we draw a normal to the interface between air and glass, here say this is the normal. Okay, and if light incident from air medium to glass medium, air medium is called rarer medium. Now this medium is called rarer medium, and glass medium is called denser medium. Okay, and it, you see the light ray AO is the incident ray and OB is the refracted ray. The ray after after incidence into glass medium is called refracted ray, and the refracted ray is bent into towards the normal. Okay, to understand this, let's see simple the motion of car. Here, for normally, if a car move from smooth road to sandy road or road filled with sand, okay, then what will happen? The speed of car will decrease. Okay, but for normal incidents, means when car move from normally from smooth road to sand road or mud road. Okay, so front wheel to front wheel of the car enter into second medium at the same time. So two wheel will slow down at the same time, so it will not bend anywhere. Okay, it will move straight. But when car move obliquely, incident obliquely enter to sand medium from smooth road. Okay, you see, suppose see this picture. This picture you see the right wheel entered into mud, but left wheel still in smooth region, smooth road. Okay, so what happened? This wheel will slow down, but this wheel has speed intact. Okay, so it will bend like this. So the car means the motion of car will change like this. Okay, that's like this. For light, you see when the light move from rarer medium to denser medium, the light bend towards the normal. Okay, similarly for normal incidents, here also you see for normal incident light will not bend. Okay, in which direction will it bend, right? So it will incident normally. Here you see when light move from denser medium to rarer medium to denser medium, you see it bend towards normal. But when light move from denser to rarer, this one is called denser medium and this one is rarer medium. Okay, and then the light will bend away from the normal. Okay, this one is air medium or rarer medium. Okay, and why it bending? Because its speed change. Okay, due to changing speed. Here for motion of car, you see why the car is bending? Due to the changing speed of its wheel. Okay, different wheel. Like this, when light move from one medium to another medium, its speed also changes. Okay, so partial reason. Now let us understand the partial reflection and refraction of light at the boundary of the medium. Partial refraction means when light incident from one medium to another medium, it will not completely refracted or completely reflected, partially refracted, partially reflected. Let me show you one animation. Okay. Here you see this one is the interface of between two medium. This one is the normal. Okay, and let's switch on the light. Okay, this one is the light. You see, this one is the incident ray. Okay, and this one is the refracted ray or refracted beam, and part of light reflected here. You see, if I change the angle of incidence, you see the angle of, we know for reflection angle of incidence equals to angle of reflection always, but for but angle of incidence not equal as the angle of refraction. Okay, for normal incidence, you see light is not bending any direction, it is normally incident here. Here angle of incidence and angle of reflection are same and which are 0 degree, right? Okay, you see for oblique, if we increase the angle of incidence, you see the intensity of reflected beam increasing and intensity of refracted beam decreasing. Okay, okay, moving to our main part. So this one is called partial refraction, means part of light reflected and part of light refracted. Okay, now law of refraction, like the law of reflection, we have law of refraction. First law is, we all know, the angle of incidence, angle of incident ray, reflected ray, and normal to the interface of two medium of the point of incidence all lie on same plane. Okay, they all lie on same plane like this. Suppose this one is the plane. Okay, one ray is incident in this one the ray and this one is the normal. Okay, so refracted ray will go this direction, not it will go this direction or this direction. Okay, it will go, it will set on, sorry, this one is reflected ray and also for refraction also they will on same plane. Okay, like this. And second law is very important law, that the relation between angle of incidence I and angle of reflection is called R. So this one, when ray move from one medium to another medium, suppose light ray moving from medium 1 to medium 2, and angle of incidence in medium 1 is I and angle of refraction in medium 2 is R, then sin I by sin R, we all know what is sin, trigonometric rule, height by hypotenuse, and sin I by sin R is constant, and which is called mu. Suppose mu of second medium with respect to first medium, it can be written as 1 mu 2. 1 mu 2 means refractive index, this one is called refractive index, refractive index of second medium with respect to first medium. Okay, this is the law of refraction. So here, if light move from second medium to first medium like this, suppose this one is second medium, this one first medium. Okay, this one is the normal. If this one is angle of incidence and this one suppose angle of refraction. Okay, so here I is the, this one is I, this one is R, and also I have chosen that first medium is a rarer medium and second medium is denser medium. So here also we can write sin I by sin R equals to, so second medium, here the light refracted incident medium is medium of incidence ray is second medium. So here the mu will be first medium with respect to second medium. Okay. Sin A by sin A. So this is the second law of refraction. Okay. And also I have told you that when light move from one medium to another, why it is bending? Because speed changing. Okay. So refractive index, the relation there is a relation between refractive index and speed of light in medium or between mediums. Okay. So refractive index of second medium with respect to first medium is the equals to speed of light in first medium with respect to speed of light in second medium. Okay. So 1 mu 2 means refractive index of second medium with respect to first medium. Okay. And V1 is the speed of light in first medium, and V2 is the speed of light in second medium. Okay. 1 minute. If we want to find out the refractive index of first medium with respect to second medium, suppose refractive index of first medium with respect to second medium, then we can write 2 mu 1 means refractive index of first medium with respect to second medium. This can be written as V2 by V1. Okay. Okay. So you can compare these two equation. Okay. You can compare these two equations, then you can get 1 mu 2 equals to 1 by 2 mu 1, right? Means 1 by 2 mu 1 means V1 by V2. 1 by 2 mu 1 equals to V1 by V2. Okay. So 1 mu 2 equals to 1 by 2 mu 1. Clear? And you see the mu proportional to here 1 by speed. Okay, let me show you in next page. So here one headline written that condition for light ray to pass undeviated on refraction, when the light will not deviate during passing through one medium to another medium, when angle of incidence equals to 0, then angle of refraction will be 0. And another thing is when light ray move on same medium, means will not move from another medium to one medium to another medium. Okay. Here written when angle of incidence of light ray at the edge of two mediums should be 0 degree. The refractive index of the two mediums should be same. Okay. When light move from glass to glycerin, in water to glycerin medium, both have same refractive index, so light will not bend. Okay. If any one of the above two conditions fulfill, then the ray of light will pass undeviated on traveling from one medium to another medium. Okay. Here I told you refractive index. So refractive index, I told you 1 mu 2 means refractive index of second medium with respect to first medium. When if the first medium is air or vacuum, okay, here first medium, this one is second medium. When first medium is vacuum or air, okay, then refractive index of second medium, then refractive index of second medium is only called only mu. Okay, or you can write 0 mu 2 or only mu. You can write mu. This one is called actual refractive index. Okay, mu, which is called actual refractive index, means refractive index with respect to vacuum. Okay, this is called actual value. Suppose in physics you got 80 marks. That means you got 80 marks greater than 0. Means with respect to 0, if you compare with respect to 0, then you get 80 marks. But if you compare to another person who got 60 marks, then you got 20 marks greater than him or her, right? Like this, actual refractive index and refractive index with respect to 0 medium. 0 medium means vacuum. Okay, so this can be written as C by V. Here C is called speed of light in vacuum, equals to, we know, 3 into 10 to the 8 meter per second, and V is the speed of light in air medium, in denser medium, or in medium, given medium. Okay, in given medium. Okay, this is called C by V, and C always constant. We know speed of light in vacuum always constant. So you can write mu proportional to 1 by V, which is called actual refractive index, Okay. And this actual refractive index also varies with color of light, because here mu equals to C by V. C is always constant. V equals to, we know, nu lambda. Okay, here nu is called frequency and lambda is called wavelength. We have proved in class 9 also, V equals to F lambda for sound wave. Okay, like this wavelength. Here F is replaced, nu is replaced by F, wavelength of light. Okay, also nu cannot be changed. Okay, this is the specific property of a specific color of light. Okay. For particular color of light, nu is always constant. For green light, it has particular frequency. For red light, it has particular frequency. For yellow light, it has particular frequency. But lambda varies with medium. Lambda can be vary with medium. Okay. Also, C can be written as nu lambda naught. Lambda naught means wavelength in vacuum by nu lambda. Okay. So mu can be written as lambda naught by lambda. Lambda for a particular light, or lambda naught by lambda, or C by nu lambda. Here you see mu proportional to 1 by lambda. Okay, C is constant, frequency for particular light constant, and we know for wavelength is different for different color of light, right? So for different color of light, okay, for particular medium, different color of light, for different color of light, mu can be varied. Okay, so we know that lambda red color wavelength is highest, then lambda orange, then lambda yellow, then lambda green, then lambda blue, then lambda indigo, then lambda violet, VGF. Okay. And also as mu proportional to 1 by lambda, so mu r less than mu orange, less than mu yellow, less than mu green, less than mu blue, less than mu indigo, less than mu violet. So for particular medium, suppose air or glass medium, mu refractive index changes with changing wavelength, means changing color of light. Okay, so for different color of light, refractive index will be different. Okay, and for different medium also refractive index will change. Okay, and apparent refractive index means when light move from one medium to another medium. Two medium, not two medium. This one is medium 1 or medium A here written, and this one is medium 2. Then we can write 1 mu 2. Then it will be V2 V1 by V2. Okay, or here you can write 1 mu 2 means sine I by sine R. So and another things, if I want to find out the relation between actual refractive index and relative refractive index, what is the relation? See, suppose 1 minute. Suppose one ray moving from one medium to another medium. Okay, so if I want to write for medium 1 mu 1, it's C by V1. This one is actual refractive index, actual, and for mu 2 C by V2. Okay, but if I write 1 mu 2 means refractive index of second medium with respect to first medium, we can write V1 by V2. Okay, so if we multiply C in both sides, then you can write C by V2 by C by V1, right? That means 1 mu 2 means C by V2 means mu 2. Here mu 2 is C by V2 and mu 1 is C by V1, mu 2 by V1. Okay. This one another equation, 1 mu 2 means mu 2 by mu 1. Okay. So what we learned, that actual refractive index mu equals to C by V. That means mu proportional to 1 by V in gist, in form of gist. Okay, and mu can be vary with medium. Okay, for red light mu is minimum, for violet light mu is maximum. Okay, and 1 mu 2 means mu 2 by mu 1. Mu 1 mu 2 is the actual refractive index of second and first medium. That means we can write V1 by V2. Okay, or you can write lambda 1 by lambda 2. Yeah, these two are the equations. And also we have, suppose if I took that there is two medium. Okay, one light is incident angle I1 angle, one light falling on another medium with angle I1, and angle of refraction is suppose I2. This one medium has refractive index mu1 and second medium has refractive index mu2. Then you can write that 1 mu2 equals to sine I1 by sine I2, right? That means 1 mu 2 means mu 2 by mu 1 equals to sine I1 by sine I2. Okay, if we multiply diagonally, you see mu 1 sine I1 equals to mu 2 sine I2. Instead of 1 mu 2 equals to sine I by sine R, this equation is more familiar than that. Okay, because here probability of accuracy will be greater. Means to do numerical problem correctly, this equation is better for that. Okay, now see the one application, refraction through multiple medium. Suppose here A, B, C, we have mu refractor mu A, mu B and mu C. Okay, and here suppose this one is air medium. Okay, suppose and the refractive index is mu naught, suppose. For air medium, refractive index, we know for air medium refractive index is 1, okay, because mu equals to c by v, here v equals to c, c by c equals to 1, okay, for air medium. So suppose this one is I naught, okay, and this one suppose a medium IA, okay, this one will be also IA, this one will be IB, this one also will be IB, and this one suppose IC, this one also IC for C medium, and this one will be, what will be this angle? Suppose I naught dashed I am taking, okay. Now for air medium and A medium, you can write mu A equals to sine I naught by sine IA. For A and B medium, you have to write mu BA equals to sine IA by sine IB, okay, like this. For BC medium, mu CB equals to sine IB by 1 minute sine IB by sine IC, like this. Like this. But you can easily remember this one. For air medium, suppose one air medium, we know the refractive air is 1 sine I naught equals to, for a medium refractive index is mu, actually sine IA equals to, you can write mu B sine IB equals to mu C sine IC equals to, then again it reaches into air medium. So here you can write mu air means 1 equals to 1 sine I dashed, suppose I not dashed. This is the equation, okay. This one is more familiar than that one. So here from you can see this sine I naught equals to sine I naught dashed, right? Sine I naught equals to sine I naught dashed. That means I naught equals to I naught dashed. That means incident ray and refracted ray both are parallel to each other. So incident ray and refracted ray both are parallel to each other. Okay. Here also you can see refraction of light through rectangular glass block. Here for first interface, PQ interface, you can see for this picture, for PQ interface you can write 1 sine I equals to, for glass, suppose mu G, refractive index of glass is mu G sine R, okay. And for SR medium, SR interface, here this one, okay. For SR interface you can write this one will be R, right? So here mu G sine R equals to, means sine of angle equals to refractive index is constant for every medium, okay. Mu G sine R equals to, this one is 1 refractive index 1 sine E, here written E, okay, sine E. So here you can compare these two equations. You see sine I equals to sine E. That means I equals to E. Angle of incidence equals to angle of emergent, right? So these are the practically Here light incident light, this one is the incident light, and after reflection these are the refracted light. And you see here angle of incidence, this one is angle of incidence. If this one is I, then this one should be I. Okay, and this will be R and this will be R. Okay, this one equal refraction of light through rectangular glass block. Okay, now let's do some numericals. Question A. A ray of light entered a glass slab PQ as shown in diagram. Okay, the critical angle of, sorry, this is not in our theory. Here the velocity of light in diamond is this much km per second. What is the refractive index? So I told you actual refractive index means mu equals to C by V. Here V given 121,000 km per second. We have to convert meter per second, 10 to the power 3. So now put 3 into 10 to the power 8 by V 121,000 into 10 to the power 3. That means 3 into 3 square by 121 means 300 by 121. Okay, you can calculate this one. Another problem is here refractive index of water given 4 by 3, refractive index of glass given 1 by 1.5. Find out the refractive index of water with respect to glass. Means we have to find out refractive index of water with respect to glass. Mu G mu W. That means mu W by mu G. Mu W here given water 4 by 3 and mu G is 1.5. This one is the refractive index of water with respect to glass. That means 4 by 3 1.5. 1.5 means 3 by 2, 8 by 9. If you want to find out refractive index of glass with respect to water, then it will be mu G by mu W, and this will be 9 by 8. Okay, inverse of I have told you that W mu G equals to 1 by G mu W. Okay, these are two problems. That's all for today's class. Next class we'll discuss more about refraction of light.